I am assuming that you already know what is graph, what is node, what is edges. Still, I'll repeat. Adjacency list and adjacency matrix. Graph is a nonlinear data structure. So you want to store this nonlinear data structure into a linear data structure, something similar to array, basically that is dynamic array and one 2D array. Adjacency list and adjacency matrix, both of these contains adjacent. So somehow we'll store some information about adjacent node to the current node. Adjacent node is like the nodes that are directly connected by an edge to that node, and adjacency list is like it store the list of adjacent nodes. Basically, let's say you have a graph like this: 1, 2, 3, 4. Now 1 is connected to 3, 3 is connected to 2, 2 is connected to 4, and 3 and 4 are connected. If you want to store in adjacency list, so for each element, for each node, it will have some place to store the list. Let's say this is a dynamic list, so we'll store in the first place. Let's say we will store this all the adjacent nodes of this first node. So the adjacent list is like there is only one, that is 3, so we'll store here 3. And in second place, let's say we'll store the nodes, adjacent nodes for this node 2, so that is basically 3 and 4. So we'll store here 3, and another memory location will be allocated, that is 4. Then in third place, we'll store all the adjacent nodes of this node 3, that is basically 1, 2 and 4. So we'll store here 1, 2 and 4. Now for this fourth one, we'll store adjacent nodes of this 4, that is 3 and 2. So we'll store here is called adjacency list of this graph. Let's implement in C++. Here let's say we are creating a class, let's call it as graph adjacency list. So we'll be storing inside a dynamic 2D array called adjacency list, and there will be variables like number of node and number of edges. Then we'll create a constructor graph adjacency list, node ll n edge. Now yes, now we have to initialize this adjacency list, and we'll store this n node and n edge to this n node and n edge. So first let's store this this n node. This n node is this one, like object for this class. This n node equals the n node that comes from here. Similarly, is equals n is. Now we'll initialize this one, this part, that will be like it adjacency list equals vector of ll. This will be of size n node. Now this data structure is created. Now we'll take input. Let's say it's called void add is. Let's say there is an edge from node X to node Y. We'll add, let's say 1 and 3. So we'll add 3 in 1 and 1 in 3. That will look like ADJL. Let's say, let's take it at node plus 1, so that the indexing is like 1, 2, 3, 4. Now this adjacency list, in X we'll push back Y. Y is adjacent to X. Similarly, we'll push X in Y. That is, X is adjacent to Y. Take a function as input. We'll call X comma Y. We have that adjacency list ready. Now we'll print and see if the adjacency list is correctly formed or not. N node from 1 to N, and for auto all the adjacent nodes in adjacent nodes. Now we'll print this adjacent node. After like printing all the adjacent node, we'll simply print end line, and before that we'll print node number. Now let's add the graph. In this example it's like 4, and the edges are also 4. Now dot add is 1 cross 3, 3, 4, 2, 4. Now we'll print the graph, print adjacency list. Let's run this and see if we get this adjacency list or not. Okay, see, in node 1 the adjacent is like 3. In node 2 the adjacent is 3 and 4. That's correct. In node 3 adjacent is 1, 2 and 4. 1 for 3, 1, 2 and 4. And for node 4 adjacent are 3 and 2.